Hi guys, welcome to this page of the notes. What we're going to do now is we're going to look at that third product theorem, the secant tangent product theorem. On the first page of the notes we looked at the chord product theorem and how we can set up the product theorem for the segments to solve geometry problems. We then looked on the last page of the notes at the secant product theorem and how we can use the secant segment and the external secant segment to set up a product theorem to solve for an unknown. And now finally, the secant tangent product theorem. Now, we know what a secant line is. A secant line is going to be a line that intersects a circle at 2 points. We know that a tangent line from the previous section is a line that intersects the circle at just 1 point, which we call the point of tangency. What's going to happen here is as well, they're both going to have a common endpoint, which will be our circumscribed angle, which we talked about in the previous section. Here's the way the theorem is going to work. Again, ton of words for something that actually really isn't too terribly tricky. Let me show you how it works. First, I have a secant segment AC. Secant segment AC. That secant segment will also have an external secant segment BC. And all of that has to be equal. So my secant segment multiplied by my external secant segment, AC times BC, must be equal to my tangent. This external tangent piece, right? DC is my tangent line. But that has to be squared. DC squared. Right? That's it. That's the secant tangent theorem. Secant segment times the external secant segment must be equal to your tangent line squared. Okay, well, let's see how this theorem applies in some problems. Here we go, first one. Alright, what we're going to do, you are given that the diameter of the Earth is 8,000 miles. The diameter of the Earth is 8,000 miles. In fact, I give it to you right here. There is Earth. I drew a diameter inside of there and labeled it 8,000. I just didn't put the units of miles, but there it is, 8,000 miles. Now, a satellite orbit. So the satellite's orbit is 6,400 miles above the Earth. I didn't put that in my diagram, but you can do so right now. Right there. It is 6,400 miles above the Earth. So 6,400 is going to be that guy right there, SE. Here's what I want you to know. What is the range of the satellite shown by SP? I want to know this guy right here, SP. Go ahead and put your X right there. I want to know what the range of that satellite is. It is the tangent segment. We're trying to find the length of the tangent segment. So here we go. Find the range of the satellite. Okay, great. Let me draw a blue line in there for you as well. Here's the way it's going to work. Please notice that you will have to set up first your secant segment A to S multiplied by your external secant segment ES, and that all has to be equal to your tangent segment SP, but SP is squared. Okay, well, now that that's the geometry, algebra from there. Here we go. What I need to do in order to find AS is I'm going to have to add 8,000 plus 6,400. So I will have 8,000 plus 6,400. That's going to be multiplied by ES, which is 6,400. That'll all be equal to X squared, right? Why? SP is my variable. That's X. So that's what I'm trying to solve for. Okay, great. Well, 8,000 plus 6,400 is going to be 14,400. That's going to be multiplied by 6,400. 400. That all has to be equal to x squared. You can do that real quick on a calculator. Just don't fat finger something. You wind up with an enormous number. X squared is equal to, I get, geez, what do I get? 92,160,000. Big number, big number. But that's not my answer, right? I'm trying to solve for x, and I have an x squared. So how do I solve for x? Yeah, algebra says take the square root of both sides. X is going to be equal to 9,600. And of course, the units on that will be miles. So the question was, find the range of the satellite. Well, the range is SP, and it turns out SP is 9,600 miles. How did we find it? We simply set up the secant tangent product theorem. Secant tangent product theorem solved that one for us. I got another one for you. Let's keep going. Ooh, exciting stuff. We're bird watching today. So, a bird watching trip, you travel along a path tangent to a circular pond, to a lookout station. If you're going to watch birds, you might as well be in a lookout station. It faces a hawk's nest right there. See, there's the nest. My lookout station's over here. Given the measurements on the diagram, I want to know, right on my bird watching map, how far is the nest from the lookout station. I actually labeled that on there for you. You can see in your diagram, from the nest to the lookout station, I have that labeled as X. Okay, here we go. Let's set it up. Actually, I didn't put any points in here, so let's go ahead and put some points in here. I'm going to call the nest point A. I'll call that guy right there B. I'll call the lookout station C. And that point of tangency right there is D. So there's D, C, there's point B, and there's point A. In fact, let me put the points in red so that you can see them a little bit better. All right, there's all my points. Very clearly looking at the diagram, right, I have a secant segment, an external secant segment, and a tangent segment. How do I know that? Well, they both have the common endpoint. This line only intersects the circle at one point. That makes it a tangent segment. This guy intersects the circle at 2 points. That makes it a secant. So this is going to be the secant tangent product theorem. So here we go. Set it up. I'm going to have my secant segment, which is AC, multiplied by the external secant segment, which is BC. That all has to be equal to the tangent segment CD, but that has to be squared. All right, now we plug in what we know. What is AC? Well, on the map, AC is X. That is going to be multiplied by BC, which I tell you is 25 yards. 25. That all has to be equal to CD, which in this case is 100, but that's got to be squared, so 100 squared. All right, here we go. I have 25. X is equal to 100 squared is 10,000. Divide by 25. X has to be equal to 400. What are the units? Well, all the measurements are given in yards. So our lookout station, right, where we're doing our bird watching from today, is going to be 400 yards from that hawk's nest. Bring a good pair of binoculars with you. What that does, guys, is we have now gone through all three product theorems. The chord product theorem, the secant product theorem, and now the secant tangent product theorem. I had a great time taking a look at these problems with you where we use a little bit of geometry, the product theorems, to set up a problem that we then solve using algebra. I'll see you guys next time.